Hello, everyone, and welcome to another K6 Office Hours. I'm just checking to make sure that I'm not muted this week. I am not. I am
You're good.
also Nicole van der Hoeven. And today I'm with two of my colleagues, Paul Balogh. Paul, are you drinking anything today?
Just tea. I
Okay.
don't
I'm
I don't have
having,
my K6 mug though. I've got this
oh,
other one here.
disappointing.
Yeah.
Out of loop. I don't
I'm
have a mug at
drinking
all.
caramel. I'm drinking caramel cookie cappuccino.
Oh,
Sounds fancy.
nice.
And we also have Vince Huang. What did you say you're drinking?
I'm just drinking water, but I'm out of the loop because I don't even have a mug at all. It's more of a
Ooh,
Oh, wait, you don't
we know
have a
people that
K6
have
mug?
I
swag.
don't have a K6 mug. I was left out of the loop when I joined.
Oh,
Okay, well,
I
you
think
got to
one's on
talk
the
to
way though. I'm
Leandro
being
about
told. We'll
that.
see.
Yes.
loop.
You definitely have to have one for sure.
We got a
Before we
connection.
introduce Before we introduce Vince, um, one announcement is that we did release version 0.59 of K6, but rather than us just talk about it, here's a sneak peek of something that will come out on Monday, thanks to Leandro Melendez and Paul here.
Hello K6ers, I am Leandro Melendez. You are watching KSIX News, bringing you the hottest news for the latest release of the K6 solutions. Today, we will be presenting the latest news on K6 OS's release for version 0.39. So, to not wait anymore, let's jump straight ahead into our breaking news segment. To start with the breaking news for version 0.39, first, we have improved the CSV output. K6 now supports a new time format option. Now, it is possible to use the Unix format, which is the default, and as well the RFC 3399. And on top of that, you can also configure this time format through the K6 CSV time format environment variable. We must thank these improvements to our amigo Robert Pocklington. You can find him at his GitHub handle at rpocklin. There are so many fantastic contributions from our awesome amigos all over the place. And speaking of fantastic contributions, many more of them made it on this release. Following up, we must thank to Max Rogoshnikov, I hope I said your name well, or at Maximal89 on GitHub. He added the clear and delete methods to the cookie jar object from the K6-HTTP module. Now we can do much more with those cookies. And in terms of contributions, that's not all. We have also Dark A Ether with the same GitHub handle with an @ at the beginning, coming up with another contribution. This one falls into the UX part of K6. It increases the precision of the iteration progress bar in the UI. Now, you will be able to see and tell better how everything is progressing. And last, when you have problems parsing config files, now you will get improved and descriptive error messages. Because, man, it was kinda tough to figure out problems without those messages. But with this update, you will have an easier time finding and fixing those little pesky issues. And speaking of having an easier time, I think I will have an easier time on this segment, as that is it with the breaking news for this release. The reason for that is that a big part of the K6 team is taking it easy as well, with some time off to enjoy the summer. For that, I decided not to bring anyone from the beach and sun to tell us about the news. But do not worry about this show falling short. It won't. There were several fixes that made it into this release, and we will be discussing them too. But before we go there, now that I mentioned the sun and summer and all that weathery stuff, I think it's a good moment to go on to our cloud weather segment with our friend Paul. Hey, amigo Paul, how is the weather looking on these relaxed summer days?
Oh, hey. Hola, Leandro. Glad midsummer, as they say in Sweden. Happy solstice. So I've taken the advantage of enjoying the sun for a while, but not everyone on the team has been slacking. Some of our cloud updates include we've added the organizational level API tokens, which you can add to your CI pipelines. This will avoid using user credentials directly in your configuration. The test builder has been updated to allow for the creation of multiple scenarios within a single script. We've added the delete sensitive data option, which our customer support can enable for you, which will ensure that none of your sensitive data is actually stored with your test results on the K6 hardware. And Grafana Cloud customers can now use the Grafana single sign-on with their K6 Cloud account. Not too bad for a summer break. So that's all I really have for you, Leandro, so I'm going to get back to reading my book.
Awesome. That's a fantastic report, amigo Paul. Thank you very much. And there you have it with the cloud report. But as I said, don't think that I forgot all the pending fixes that we have. Let's go over them because we had several of them. To start, first, we have one that also came from contributions, lots of contributions. I'm super happy. On this one, we got that fix from @flowerc with the same GitHub handle. The fix covers a gRPC marshalling error when any.proto was used as a type. We want to thank you very much @flowerc for helping us with this fix. Next, the following fix covered the selection.map function for the K6-HTML module. Now it returns the correct object types instead of a forced array of strings. Moving on with the fixes. Before, we used to have some misleading red X's in the UI output when the scenario's executors finished before fully updating everything. Those weird X's have been fixed. So now K6 waits for them to finish. No more weird red X's here and there. Yay! On other fixes, we have a couple that fixed some wonky error messages. One of those messages is on a bug where the Go error string contained missing URL values. And on the other set of fixes, there's one where we got a wrong message on a remote resolution. Both of those have been fully fixed. They are now history. Almost done with the fixes, we have a few more. We solved a bug where rate metric and sub-metric values were shown as NaN, not a number, in the end of test summary, if there were no measured values for them during the test run. This has been fixed. And last, we have a couple of fixes around panics. One is when you try to set to null or undefined the value of a bu.tags element from K6-execution. And the other panic was when you try to access some K6-execution properties outside of a BU context, such as trying to access execution.scenario in the setup module. Wow, I told you, lots of fixes. But that is not all. We also did some improvements, like in the Go version and its dependencies, together with deprecating some warning messages. With all those news, the future looks bright and ambitious. Because, speaking of future, we have several plans. If you want to find out, please visit the release notes, where you will find some of our plans for the future of K6. For that, the link in the description below. And last, as a closing note, since, as I mentioned, many of our K6ers are out in this period, taking some vacations and off time, we will skip our community call and do the next one on release 0.40. But do not worry, if you still have questions, comments, or the usual things that we used to talk about in the community call, you can post all of those comments and questions at our community forum at community.k6.io. We will be happy to answer all of your questions and comments. And with that, we have reached the end of tonight's report. That will be it for all of us here at KSIX News. I am Leandro Melendez. You stay classy, K6. Sir, I do think that you are leaving more fur than the one that you are taking off from this. Are you sure you're qualified for this job? You're doing your best. I love you.
This is the best part.
So, what did you think of the episode? Do you think it went well? You didn't like it, right? Stop judging me. Why do you always judge me?
I personally think that was the best part.
Waiting for the cat to walk away, just like ignore him.
Yeah. So that was completely edited by our awesome other colleague, Leandro Melendez, who I think we're having on next week. I'm not entirely sure. But
Sounds about right.
now that we've got that out of the way, Vince, why don't you introduce yourself and tell us, what you're doing at K6?
Sure. Good to meet you. Good to see you, I guess. Yeah, I am a program manager at K6. I am in charge of really just kind of promoting K6 as a whole, specifically to the chaos engineering community, and trying to get folks to really folks from both worlds in the K6 and load testing and performance world to see the benefits of the chaos engineering world, and then from the chaos engineering world to the load testing world.
Okay, cool. And when did you actually join K6?
So I think the official date was 2 months ago. So I was actually part of the Grafana team before this. I was a solutions engineer, a solutions architect for Grafana. And yeah, then I heard how awesome K6 was, and I said, I really need to go there. And then I learned how awesome the people
It was us,
were.
wasn't it?
And then, and then it was, I really, really need to go there. And so I started some discussions, and everything seems to work out.
So did you specifically come to work on chaos?
Yes. I'll put it that way, yes. I think the goal was more of a K6 seems really cool, and I'd like to be able to promote promote the message between the two and kind of meld the worlds together, because a lot of it does overlap, at least in my mind, and how I see things and how I feel other people see things too. So there's a good story to tell, at least, right, between the two of the reasons why we want to do load and performance testing, and the reasons why folks want to get involved with chaos engineering.
Yeah, and it also is because of your background, right? Because this is not the first time that you're talking about chaos. Can you tell us a bit more about what you've done previously?
Historically,
You've broken things in the past.
Sometimes the past is dangerous. Yeah, so previously I came from Gremlin. I worked with Gremlin and promoting chaos engineering there, again as a solutions architect there. So I have some experience with some of the products that are out there that are available, and even before that, I was doing chaos engineering before it was even a cool thing. And so breaking things on purpose and going and trying to understand how your systems react under less than optimal situations, right? In less than optimal situations, was fun, but also has its moments, right? And so being able to share some of those experiences with other folks and with other teams, and being able to identify through different levels of observability, right? Being able to identify the way things can be done and the way things should be done, kind of works out.
I feel like Vince is the opposite of the stereotype of a chaos engineer, because I always think of like some sort of mad scientist, in their lair, and Vince is like just so soft spoken and quiet. But looks can be deceiving.
Sure. It's kind of there is a lot of misconceptions, I guess, about what chaos engineering is and who can do it and things like that, right? And so there's I think you're right in terms of like I kind of break that stereotype of that, because I tend not to be over exaggerating on movements or anything like that, or even talking, right? So uh, the point out of all of it is not necessarily like it's a misleading title, chaos engineering, right? We're not really trying to be chaotic in terms of just randomly breaking things and trying to pull the rug out from underneath anything. We are here to systematically and very carefully try to understand how our systems react, right? How our processes react to different scenarios.
So we've talked about chaos engineering quite a bit in the past, not just in other videos, but also on K6 office hours. We've had a bunch of different people come to talk to us about it, and Paul and I have both spoken about it. And I think that in this episode of office hours, I would like to go and talk more about the theory, because so far we've talked a lot about the tools, like how you actually carry it out. But sometimes I think there's an over focus on the tools, and this is something that happens in load testing too. There are too many people that just think about the logistics of actually writing the script or whatever. But if you don't know what you're doing or why you're doing it, it may be all for nothing. So I think it's really important to have a foundation, a good foundation of what chaos even is, because, like you said, there are a lot of misconceptions.
For sure, there's what it is, how we do it, right, and why we do it specifically, right, and that kind of helps us build into the tooling, like you said. So being able to understand again why we're doing specific types of experiments, and whether or not these tools can even uh, actually work with these plans.
So Ganesh has a question right off the bat.
Yep.
He says, what is the future plans? Integrate Gremlin with K6 or build it in-house?
Sure, we're going to integrate Gremlin with K6. And Gremlin itself is a closed source solution, so there's going to be a little bit of uh, conflict, I guess, with the two. Gremlin itself does have an API though, so that if you do want to, we can tie in and reach out to Gremlin and other solutions, right? Most of them do seem to have an API that you can programmatically reach out to kick off different things. A6 does have its own chaos extension that does very limited chaos engineering experiments, right? But the goal, I think, is to at least promote the fact that the two worlds can interact with each other.
Yeah, and I mean that feeds
I
in
think-
kind of with the Grafana big tent philosophy in a way too. I mean, just kind of everything kind of working together. That's so yeah, all these different chaos products that are around
Sure.
just kind of fit in and play well with others.
Yep.
Yeah, that's exactly what I was going to say, that historically the way that we've gone is just yes, like yes, integrate with everything. Yes, maybe some limited things that you can do with K6, but regardless, it's our goal is to be as composable as possible and to play well with everything else that's on the market there, because you shouldn't have to be locked into K6 because, you know, it has to do everything. It's like, no, you should be free to choose whatever tool you want and also choose K6, hopefully. So I thought that we could start with maybe the history of chaos, just to go into the past before we talk about a little bit about the present. So this is something I'm not sure if you were there with her, but it potentially an ex-colleague of yours at Gremlin, who I've spoken to a bit. She's Tammy Butau Bryant, and this is a slide from one of her awesome presentations. And it starts with Netflix. Netflix was really the creator of even the term chaos engineering.
Yeah, they built out. I know Tammy. She's helped me with quite a few things from before. So shout out to her to be able to she's moved on, I think, from Gremlin now, doing something else. But
Yes.
she's definitely made an impact in the world, in the chaos engineering community for sure. But as far as the start of chaos engineering, yeah, definitely Netflix. The folks at Netflix. Really, it was more of a they got tired of being on call. Like, that's kind of the story behind it, right? That and tired of just being paged for different things in the middle of the night, right? And so they try to be a little bit more proactive about what can they be doing to try to deal with this at 2 in the afternoon instead of 2 in the morning, right?
Absolutely.
So they built out Chaos Monkey. And Chaos Monkey was really just something that randomly shut stuff down. That's really all it was. Chaos engineering as a term was born at that point, right? So they expanded on that to do a bunch of other things, and that's where Simian Army came in. Where we're not just doing shutdowns, we're doing some latency and some other things, right? That we can go through, and yeah, and the rest is kind of as the rest of the timeline here shows, at least from a Gremlin perspective.
Yeah, that's really cool that you brought up that Chaos Monkey initially was everything that chaos engineering was. And at the time, all it did was shut down EC2 instances. And that was the extent of it. And now there are so many different types of attacks or things that you can try as chaos experiments. But I think this is also, this is very Gremlin focused just because I happen to like this slide. But there are definitely other tools that are out there. In fact, there is somebody in the comments, Nilanjan Mana, says, "Hey everyone, this is really awesome. I'm from the Litmus Chaos community." Litmus Chaos is another of these tools. Yeah, we'd love to at some point talk about Litmus Chaos as well.
Sure. Glad to
So
see you here.
So we've got chaos defined in this very small way. And can you tell us a bit about the naming, the chaos monkey? Why is it called a chaos monkey? Why
Well,
isn't it a chaos croc?
I actually don't know the story behind the monkey itself. I think they just thought that monkeys were chaotic by nature, right? And so the idea was kind of coined in that fashion. I'm not sure if there's more story behind it. I wasn't there when.
No, I
started to
think
develop it.
that was
I'm
it.
pretty sure that's
It's
where it
like
started.
us, but more of our ids, like less impulse control.
For sure.
So there was this idea of a chaos monkey that came out from the thought that one of the most destructive things that can happen is to just let a simian army, a bunch of monkeys, loose in your data center, see what they do, see what they pull out. And there's this very strong root in chaos theory, which is actually from mathematics, about how these seemingly random chaotic events aren't exactly random. Random doesn't necessarily mean unpredictable either, when there is usually something systematic that's underlying all of these events. And usually, as humans, we just tend to label things as chaotic or random when we don't understand why it happened.
Yeah. So it definitely ties into the practice of it, right? And trying to, at least when what we deem as random can still be controlled, right? And so we can, even in a scenario where we are trying to randomly unplug things, or again pull the rug out from underneath, right? It's okay, right? And so that we know that our systems, our process, our mental stability can handle all of the things that happen, quote unquote, randomly.
So, Vince, chaos engineering sounds so far like there's some sort of automated script that you run against an application with the goal of making it fail in some way. Doesn't that sound a lot like load testing?
It does. I think it does. But the catch is that it doesn't have to be. It doesn't have to be scripted, so to speak. Right? It can. It can be something that just a one-off experiment or a one-off failure can be thrown together, right? And just to see what happens, right? But for sure, it's one of those things that as a team and as a company matures, they're going to want to be able to automate and script some of these failures into the way that they do things, right? And earlier into the way that they do things, right? We don't want to wait all the way till our applications are in production before we try to understand how things are going to react. For sure, production is where the money's at, obviously, right? So we want to be able to know that we're confident in production. But there's a lot of steps before that teams can do, especially again with the shift left type of mentality to do things earlier, right? It's a lot cheaper, a lot easier to fix your software and to fix your systems and to prepare them the earlier in the software development lifecycle.
And doing that chaos in production, that can, it can justify or show that, prove that you've done the work up front, and then also find the gaps. So.
For sure. And that's how teams, when I worked with teams at other places, I tried really hard to convince them to do things in production first.
It's terrifying.
Some of them, I think only one company ever decided to do it in production first. Things went better than we thought, actually, so it worked out pretty well. But most of the teams do end up starting earlier, right? Starting in a pre-prod type of environment, whether it's some UAT or some other pre-production environment that they have. But the goal again was to at least build confidence in their systems, right? If they can handle a certain type of failure in pre-production, ideally they should be able to handle it in production, right? And so as they graduate from the pre-prod world to the production world, like it's a big step, right? And again, being able, and it's not like we're shutting off a whole data center all at once. We're taking just one instance and shutting it down, or we're taking just one network connection and maybe adding a little bit of latency, right? We're not adding 30 seconds worth of latency. We're adding like 200 milliseconds or something like that, right? To a particular call. So it's really the goal of understanding that we can start small and take really small baby steps to get to start to build some of that confidence into the production world.
Yeah. I mean, I always think of it too. It's just like with firefighters. I mean, firefighters, they need to practice with the real fire. I mean, in order so that they can handle it and see how they will handle it when the real thing comes along.
Yeah, for sure. And that's an example that we use also in terms of like just being able to practice, right? And even in our schools, right, where we practice fire drills, and some places practice like earthquake drills, right, where an alarm will go off and everyone's got to go to the corner of the room and put their heads in their their laps and be prepared, right? So
and here in the Midwest, we even throw in tornado drills as well.
Yep. I remember I grew up in the Midwest. I remember having to do some of those for sure.
Yeah, just in case we don't all turn out like Dorothy and head off to Oz. So.
Things turned out pretty well for her, actually, though.
Yeah.
So it kind of worked out.
It's funny because chaos engineering as a field is relatively new, right? But the concept behind it, I think there's this trend in software in general for old things to become new again. And the concepts behind it have always been there, right? Everyone's always known that we need to prepare for certain things. So, Paul, I'm curious, what do you think? Is there like a huge difference in this resurgence of these concepts, or is it really just the same thing in a different package?
Yeah, it's like, yeah, it's all these cycles of things, everything that's old is new again. I mean, that's just rebranded and marketed differently, but it's the same thing. But yeah.
Yeah, I think
Let's
it's the same thing
let's
for sure.
I'd also like to play something from one of the friends of the show, Victor Farchich. I can't remember how to pronounce his name.
Barchich.
But he's from DevOps Toolkit. It's an awesome YouTube channel, so check that out. But here's what he has to say about chaos engineering.
The answer to that question lies in two opposing approaches to software development and maintenance of systems. On one hand, we have people who think that things will never break. Like, hey, this is a server, I run an application on that server, and it will run there forever. That is just silly. The other perspective is to say, hey, things break all the time, downtime is inevitable, we are going to have downtime, we need to live with it. With chaos engineering, we can get somewhere in the middle. We can say that yes, it is inevitable that things break, that things go wrong, but there is something we can do to prevent from those negative effects, influences on our system to affect responsiveness of our applications. That's where chaos engineering comes in.
So I really like that clip because I think that even though there's a lot of the same concepts in there, I think that there's a subtle emphasis in chaos engineering of the shift, because previously it was all about testing and preventing failure, preventing outage, being prepared for it, whereas now it's shifting more towards accepting that despite our best efforts, we aren't
Things
going to be able to prepare for everything. Things are going to happen. Failure is going to happen. Outages will occur for weird reasons that we can't really explain. And so the shift is now from preventing that to like making sure it gets handled gracefully, or knowing how it could happen. And it is a subtle shift, right? But I think it makes a difference. What do you think, Vince?
It does make a difference. I think that there's uh and he brings up a good point in terms of, there's the mentality of things are never going to break. I've had to convince folks otherwise, that they've had that mentality and that approach. um, because software has become more complex and the way that we do things has become more complex, it's again inevitable that there's something else that could go wrong in that stream of things, right? So I think that as we like the traditional testing doesn't really, it's just not enough, right? There's a lot more now that needs to come in to not have a poor on-call experience, right? Like a lot of people, I remember at my one of my last places, one of my previous places earlier in my career, I guess, I was in charge of just, my job was really just to page someone if I saw an alert. Like that was my job. And I remember it was like a 3 a.m. call or something like that I was talking with one of the SREs, and the page went off, and he's like, yeah, just wait 15 minutes. It should go away. And this was at 3 a.m., right? Like someone had to wake up to wait for it to go away, right? And even something silly like that, where not even like there was nothing specifically wrong with the system or even with the application. It's just that there was a false positive that triggered, right? And if that happens once, okay, right, you can kind of accept that. But that's something that he became accustomed to, right? And
Right.
he had to expect this 3 a.m. call that shouldn't have to happen, right? And so that definitely was something that, like, as if it were to continue, you can definitely wear down people. It can break folks down and probably convince them to do something else, right? Instead of having to be paged every night at 3 a.m., right? Every morning at 3 a.m. So
We talk a lot about stress testing systems, but that's like stress testing people,
People,
which
yeah.
is,
yeah,
people are part of the system.
sure. And there's a couple talks out there. Adrian Cockcroft has one, and a few other folks. But chaos engineering is not just your systems, right? It is also
Yep.
your processes,
Yep.
and
Mhm.
even the people that are reliant, that you are reliant on, right? If I'm almost at every company that I've been at, there's one or two folks that those are the people that have all the answers, right? No matter what, if you don't know anything, go to this person. What happens when that person's on vacation, right? Or what happens when that person is no longer reachable and maybe has moved on to another company?
I want
There's
to
you
pursue
need to
this
figure that out.
train of thought, but maybe we can answer this question from Rashad Hassanov. Any YAML example running K6 with XK6 and Kubernetes?
So, glad you asked that. Actually, we are trying to get together some more documentation on the K6 operator, which is what I'm assuming that you're kind of going with, in that using a custom XK6 enhanced binary for K6. And yes, that's totally possible. And I know we had some information out there, but we definitely need to improve on that. But you can use the K6 operator.
Awesome. Vince, I want to go back to this idea of systems, of people being part of systems. I also want to share an anecdote that isn't really it is of me doing performance testing, but really you could argue that there's an element of chaos in it. There was a time when I was working for a company in the Netherlands, and they were an investment company, and they had a lot of people's money that were invested in different funds. Because of legal changes, they had to send out these letters, and these letters had to have information from a bunch of different sources. And my team's job was to tune that process so that the system could spit out these letters very quickly. The problem was nobody looped in customer support. And as soon as they found out that we were generating massive amounts of letters, they were like, whoa, 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 whoa. We need to slow this down because we're going to get so many of these calls and we can't handle them. There's like two people in support. So we went from having a very slow letter generation process to having it super fast, but then artificially introducing latency just because we failed to take into account chaos that extended beyond the technical aspects. That's like an example of something that you might say, someone might think at the end, oh, well, that was an unexpected occurrence. But really, there was something systematic that could have been done to figure that out. It was looping in all of the stakeholders that needed to be looped in, right?
Yeah, definitely. Those are things that, and to apply that to a software world where sometimes there are dependencies and other upstreams that, or downstreams for that matter, that are affected by the things that happen to you, right?
Yep.
Or the things that are messing with your systems, right? If you have some sort of load generation on the front end, how does that affect the calls to the database on the back end, right? Can it handle the extra 30 QPS that we're sending it? Hopefully, yes, but realistically, we don't know, right? And in theory, sure, we'd be able to do it, but again, we're not going to know until we actually give it a shot, right?
Yeah.
Climbing from 30 to 60 to 90 to whatever other set of numbers. Definitely, that's where we start to uncover the unknown unknowns, so to speak, right? We thought we had everything under control, but realistically, it didn't turn out that we did, right? And so being able to uncover some of that from your example was kind of a load test world, I think, right? Where we threw some extra calls to there, and there was a bottleneck, right?
Yeah. It's funny that it makes me think of the book, The Phoenix Project. which basically says kind of like your overall system is slow, I guess, or fast as its slowest component. And then with you having to introduce some artificial latency in there for the overall process to run smoothly, that's funny.
Yeah, and
Yeah,
even
that's
even
an
adding
excellent book, by the way.
yeah adding more calls or more QPS or more load at one point um, generates latency, like you said, right? In one way or another, and so we can also affect or influence, uh, latency itself, right? Instead of making sure that instead of, I guess, looking for the chain reaction from a chaos engineering perspective, you can pinpoint a lot more specifically, like, let's just add latency to this one call to this database, right? And so the goal, I think, out of it is, we can make sure that the individual components of our system work well through chaos engineering, and then as a whole, you start to add latency and performance testing and load testing on the top of things, and then you have a more complete and more confident set of systems.
Yeah, search for that butterfly effect where, one thing totally seemingly independent causes an effect downstream.
Yeah, and it works the other way too, where you can start with your load testing, right, and understand what the profile is of your systems, right, of your like looking for a CPU profile of a certain type of load, right, during a certain peak or during a certain set of criteria, right, and understanding what that is, and then applying that through various chaos engineering tools to say, like, this is what happens in a certain scenario without having to rely on other external influences on top of that.
Personally, I think that one damaging thing about the term chaos engineering is that it is sometimes seen as separate semantically from testing, because I think fundamentally chaos is a testing discipline, because that is exactly what we try to do with our tests. Yes, there is that slight shift in nuance of going from preventing to expecting that something will happen, but I think the role of a tester, the attitude, what it means to be a tester, of being continuously curious and trying things out and experimenting, I mean, that is the definition of a chaos engineer. So I think it should be called chaos testing.
For sure, there's a bunch of different groups trying to nail down what they really want to call it. Chaos engineering, I admit, is the sexy term, right? Like, it sounds cool. It sounds like something that people really want to get into. But then when we, at least from an engineering perspective, right, when you start talking to CTOs and like C-suite folks, chaos is not something that they want, right? They're trying to make money out of this, and this is not something that they want to introduce into their systems. So it really depends on who you're talking to, but for sure, and at the end of it, we're testing it, right? We're testing the validity of your systems. We're testing the validity of your software, how it connects, whether or not you're properly handling some of the errors that are even being thrown. Are you throwing errors at all, right? How are you handling those? And then drifting into the processes, like, how does that happen with your paging? How does that validate your escalation process, right? Is there something that does it trigger the ticket process that it needs to trigger? Does it escalate properly to the folks beyond all that? And then into incident management and problem management after that, and postmortems and a whole bunch of other fun that happens after an incident, right after an outage.
Yeah, I mean, that's one of the things too. It's like, because now with all these different services that are coming up, and people are quoting, oh yes, we 5 nines of for our service level agreement, we're gonna be up all this time. How can you really prove that? You have to know that, and then things will happen, and so how fast can you recover? And then that's what a lot of this chaos stuff will kind of root out as well.
Yeah, for sure. And gas and testing, right? Gas testing really will cover all of that, right? So it's not just the 1 or 2 experiments or the handful of experiments that's going on. There's that whole there's the end-to-end test that needs to happen, right? There's
Yep.
end-to-end validation that needs to happen for all of that to come across.
So I think any discipline of testing has these dials that a tester can go through. Like you turn one dial up all the way, see how the system responds, then maybe turn that down and try another dial. In load testing, some of these dials might be the number of virtual users or the think time in a script. These things affect how much load is going out and what exactly you're testing. Can we talk a bit about what those dials are for chaos engineering? Like we've already talked about how Chaos Monkey is about shutting down EC2 instances. So are there other dials other than terminating instances?
Yeah, there's a bunch. Terminating instances is the easiest, I think, for sure, right? Like, let's just turn it off and see what happens, and then turn it back on and then see what happens again, right? And there's that's one thing that testing and the chaos steps really help to understand that when we turn something off, one thing happens. When we turn it back on, something else should happen, right? And we want to be able to how long does that take, right? And there's some extra latency on top of that, which is another one. Again, we talked a little bit about latency and just adding a few hundreds of milliseconds more to a database call, right? How long does that back things up, right? And starting to do that at scale, right? In terms of one call with an extra 50 to 100 milliseconds is okay. What about 1,000 calls with 50 to 100 milliseconds? So adding latency to that, and latency coming from what, right? There's a packet loss failure that you can introduce where maybe it's not something maybe it's just a faulty connection from one reason or another, right? So we can add packet loss into that. And then if it's totally gone, right? But we don't want to shut it off. Maybe a black hole scenario, right? Where network connectivity is just gone, but that doesn't mean that your database is actually switched off or anything like that. Maybe a monkey came in there and unplugged the network cable. Right? So from a network perspective, there's that set of failures. You can go through and kill specific processes in terms of going through. Maybe you just lose your Nginx process for one reason or another, right? And maybe there's a kernel or there's some other type of panic that happens that causes your application to restart for one reason or another, right? And then there's things like time travel, which is interesting because a lot of folks don't really think about time travel to be something that's important because it doesn't really happen often in terms of the need for it. But when you start to validate something like your certificates expiring, right, or even something as from a cross-colo replication perspective, right? Like maybe there's some sort of setting that carries across for that it shouldn't have, right? Where now we're writing from two different time zones, even, right? And your destination really doesn't like that, right? So there's a handful of different failures that from a tooling perspective, right? And then again, from the processes and personal like people perspective, you can add similar concepts, right? We talked about taking one person out of the loop, but what if they're there, but it takes a little extra time for them to respond to something, right? How else what else can you do instead of that, right? So instead of maybe having them not respond, maybe they respond, but they're doing something else, and so they'll only respond every 5 minutes, right? So again, adding latency to the people side of things, right? So it's not really just the systems and the software, but again, process afterwards.
It's kind of like Paul in that video of the news, right? Like Leandro was passing it over to him, and he's just like living his best life
Just
with
chilling.
the book.
Yeah, making sure my nose doesn't get all burned, sunburned.
Yeah, I want to talk to that Paul. He seemed really chill. But it also strikes me that one of the fundamental differences between traditional load testing and chaos testing is that traditionally speaking, load testing is more like black box. You're controlling, like, all of those dials that I mentioned are from the generation side. They're not on the application side at all. So it's kind of like your test is here and the application is there, and you're just sending a bunch of stuff over there, and that stuff changes. But with chaos testing, it's like it's not a black box because we are looking into changing the application itself. And I think it's less about questioning, like, when will this time travel thing actually occur, or like, in what situations would we have packet loss. This is where it doesn't matter so much when or how it gets to that point. It's like, at some point this will probably happen, so let's just start from there and see what happens to the rest of the system. It's a very it's like a very destructive, in a white hat kind of way, way of looking at it. It's very appealing.
Yeah, being able to again pinpoint the different types of failures and where they actually occur is super useful, right? But without things like the load testing step, right, to understand where things could break, even to begin with, like helps you know where to start at the very least, right? If you start throwing some load at the front and you see 400s and 500s at the on the front end, then you can start to dig down. Oh, well, that's because of this. I'm overloading my back end for one reason or another, right? And there's some latency coming back from there. So we can start to, instead of breaking everything at the top, let's break everything at the bottom first, right? And build our confidence as we move up the stack, so to speak. But I think that even with tools like K6, where you can add latency, even, or not latency, but virtual users from different geographies, right? Different geopoints is a huge thing, right? Being able to it's not just pristine, like just from my local machine type of thing. I'm actually making a call from Hong Kong, right, where my servers are in Eastern Europe or something like that, right? Where how does that extra hop, or those few extra hops, make a difference, right? So, and then ideally, right, with the different observability tools that are out there, you'll be able to uncover, like, oh, well, there's some extra, there's a delay here, and we need to reproduce that specific delay so that we can fine tune our application so that at the top everything works out.
We've got a good question here from Rose Landroche. For someone who is completely new to implementing chaos, what resources would you recommend?
Great question. Because most of the folks that I've talked to kind of stumble into chaos engineering, right? They have been on call, or they've been in the ops world where they've had to answer a page, right? Or they've had to deal with an issue or anything like that. I think it's an introduction to what can break, right? So which is why I think the load testing step is really important, to see where things can break. A lot of times, companies will ask, well, where should we start, right? How do we get started in chaos engineering? And my first question to them is, well, tell me about your last tell me about your last on-call experience. Tell me about your last outage, right? Let's reproduce that. Let's see what happens. Let's go over that timeline of what happened. Why did it take you 3 hours to fix this issue, right? And we can start to see that, oh, well, I had a problem receiving my first page. It didn't come in until 20 minutes after this incident started. Well, then we can start to go after the different types of failures of introducing that reaction, right, to folks. But I hope that answers enough of the question. But I realize that there are chaos engineering books that are out there. I'm kind of a fan, I'm kind of not, because it's more of an experience type of thing, right? You can
Yeah.
read about chaos engineering all day, right? There's quite a few talks on it. There's quite a few websites and things like that on it also. But a lot of it comes with just seeing that things can break, right? Once you've come to that realization, you're a natural chaos engineer at that point. You're a natural chaos tester, right? And again, I didn't realize that I was doing chaos testing when I was doing it, right? I was part of a team that we had a data center in Chicago, a data center in LA, and we didn't use our data center in Chicago until we told people that we had one, right? And they said, well, what happens when we shift traffic from one side to the other? Well, we don't know. We've never done that before. So let's try it, right? And so they did a bunch of validation and pre-production, trying to make sure that it could happen. And I still remember it, our very first Thursday morning, 6 a.m., said, let's shift some traffic from one side to the other. At 3% of traffic, our Chicago data center fell over. And it took us 5 hours to recover from that, right? And so, it's that version of let's try to break it and see what happens. When you have that mentality of trying to understand and trying to get a grasp of how your systems react and how your processes react, I think you're there.
I think from a practical side, I would recommend starting with load testing, because I think load is one of the chaotic elements that you can inject, and it is more mature as a discipline, which means that there's a lot more about it. I think it's a handy place to begin. But then also, I think Gremlin has put out a lot of content. I really don't have any tie to Gremlin, just they have great content. But they also have a boot camp. And in that boot camp, you will get access to Gremlin, and you'll actually carry out chaos experiments. And I highly recommend that, because that's like learning by doing right away. And they do also go into some of the theory and some of the concepts. But I wouldn't stick with just one tool. I would also look into a bunch of the open source chaos engineering tools that are out there. Like, we already saw someone from the Litmus Chaos community, but Chaos Toolkit is also a good place to start. Paul has just recently did an office hours on XK6 Kubernetes, and there are, like we were talking about, starting with terminating instances being the easiest way, or like the thing that everybody starts with. That's already something that you could do. And I think just generally letting your curiosity lead you.
Yeah. There's
Oh,
there's a
and,
big
Phoenix Project too, right? Let me actually put the link to the
Oh, there we
book.
go. Yeah.
Not
Yeah.
ours, but I think it's a really good one for learning what can go wrong.
Yeah. 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 And like Vince was mentioning too, that just start with those things that have been a headache in the past, or that happen more often than they really should. Just make it easier, so you don't get those midnight calls or 3 a.m. calls, because that's the worst.
okay if it happens once or twice.
Exactly. Yes.
But it's the repeaters that really bite you and really get to you.
Yep.
One of the things that I had a VP that was really big on repeaters. Like, it was okay if we had our 3-hour outage. I just don't want a second 3-hour outage.
Right.
So
Yep.
yeah. So that's another thing for sure, that it takes a little bit of, sometimes it takes a little bit of effort to convince some of the upper management that things are going to be okay, right? But that's where we want to be able to say, like, hey, we're taking baby steps, right? We're trying to build our confidence with very small steps. We're not just going to unplug a whole data center.
Yeah.
So we are running out of time, but Vince, a last bit of advice from you. What would you say to someone who's just getting into chaos engineering?
Yeah, I think it's just attitude. right? Just the not just of yourself, but the folks that are around you, right? Of knowing that things will break, and we want to be prepared for the times that things will break, right? And just being aware that again that we can be ready for the things for those types of events. And it's not just
Yeah, I can't agree more. I think a chaos engineer's favorite question is what if?
what if? What if this doesn't work, or what if this does, right? And that's the other side of it. What if this
Yeah.
does? Is how long will it work?
So Vince, thank you so much for coming on the show with us. It's been great to have you as part of the K6 team. I'm glad we kind of stole you away from Grafana, but I hope this
Me
won't
too.
be the last time that you're here.
No, it's definitely been fun. I'm going to try to hang out more.
Awesome.
Okay. Well, thank you everybody for hanging out with us on a Friday, and we will see you next week. Bye.
Yes. Enjoy, everyone. Bye-bye.